Hi everyone. So, hope your first week of distance learning has been a smooth transition. So now that we finished our Chapter 9 quiz and Lesson 10.1, if you need a little refresher on that, you could just always go back and watch the video, look at the OneNote. You can email me. A lot of you have been emailing me back and forth already to clarify things, and I really appreciate you doing that. Keep it up. Now what we're going to do for this week is we're going to get into arithmetic sequences. That's what 10.2 is about. Basically, we're going to learn about those and their relationship with linear functions. Our success criteria that we're going to have for this is I can successfully find the common difference of an arithmetic sequence, aka the pattern. I am able to write the terms of an arithmetic sequence. I can confidently use the formula for the general term of an arithmetic sequence, and I am able to use the formula for the sum of the first n terms of an arithmetic sequence. This is called a series. When you add up the terms within a sequence, it's called a series. So an arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. That constant amount is going to be the common difference. All right, so basically, arithmetic means that the pattern is to add or subtract that common difference, that D. All right. Here are some examples of the common difference. All right. The arithmetic sequence, 142, 146, 150, 154, 158. We see that common difference would have to be 4. That is the pattern. We keep adding 4, adding 4, adding 4, and so on and so forth. With the next one, it's -5 to -2 to +1, 4, 7. The pattern is to add 3. And then with the last one, the pattern is to -5. If you ever want to figure out the common difference, what you would have to do is take a of n, so take a term, any term you want, and subtract it by the previous term. All right, n minus 1 is the term before the nth. So that's how we got the 4, the 3, and the -5. So now you probably saw these graphs. I talked about them in our last lesson. And then you saw them on one of the problems on our 10.1 homework. Okay, now when you see a graph like this, I'm giving you all of the answers. Your x-axis is your n, all right? So if you have an x of 2, that means your second term. What answer will you get in this case? You will get -2, all right? So a of 2 is -2 in this case. If you graph your arithmetic sequences, you'll notice that since the pattern is to keep adding or subtracting the same thing, arithmetic, they are linear. They make a straight line. So think about that rate of change, your slope, as that common difference. That's the pattern. So basically, for an arithmetic sequence, if you want to figure out a problem, this is the recursive formula. Remember, it's recursive because we're using the previous term to find our next term. All right. So all you have to do is take a term, add your common difference, and you will get the next term. If you see it as a linear function, this is how you could also see it. Okay, think of your common difference as your slope, okay? And a of 0 would be the 0 term, which usually we don't get a 0 term. We usually do the first term. That would be your y-intercept in a way. All right, so you could kind of write it in that same way. If I asked you to write the first 6 terms of an arithmetic sequence where a of 1 is 6 and a of n equals a of n minus 1 minus 2, okay, basically I'm telling you the pattern, your common difference is 2 minus 2. Keep -2, -2, -2. So the first term is obviously 6. I gave it to you. If you get a recursive formula, the first term will always be given to you. So to find the second term, I got to take the first and -2. So 6 minus 2, I get 4. Now the third term. You got to take that second term, 4 minus 2, you get 2, and so on and so forth. Remember, be careful with your recursive formulas, because if you mess up, let's say I messed up a of 3. Let's say it wasn't, I got 3 instead of 2. Okay, I made a little mistake. That's going to mess up all the next ones. It'll mess up a of 4, a of 5, and a of 6. Okay, so just be careful when you're doing this. If you see them all written out, you'll see it's just the same. I'm just going to erase that. Okay, so what I'd like you to do is check point 1 on your own, pause the video, and see what you get for the first 6 terms of the arithmetic sequence. All right.